Have you ever stopped and wondered how your favorite apps can juggle millions, even billions of bits of data without just collapsing? Well, the secret is a surprisingly simple and, honestly, really elegant idea. And today, we're going to pull back the curtain and see exactly how it works.
At the heart of it all, the big problem is just repetition. We've all done it, right? Typing the exact same piece of information into a spreadsheet over and over again. It gets messy fast. But the fix for this is so fundamental, so logical, it's kind of beautiful.
So the first thing anyone thinks to do is just throw everything into one big table. Keep it simple. You list your superheroes, you add a column for their team, maybe another column for their team's headquarters. What could go wrong? Well, as we're about to see, this simple approach is a trap that can quickly spiral into a total data nightmare.
And here we go. Look at that. The problem pops up almost immediately. We've only got a few heroes in here, and we're already repeating ourselves. Iron Man is an Avenger, their HQ is Stark Tower. Spider-Man joins the Avengers, his HQ is Stark Tower. We've now typed Avengers and Stark Tower twice. This is data duplication, and in the world of databases, that is a huge red flag.
And this is where the real trouble starts. Let's say the Avengers move to a new base. Now you have to hunt down every single record for every Avenger and change the HQ. If you miss just one, your data's now lying to you. It's inconsistent. It's not just messy anymore, it's a ticking time bomb for errors that in the real world could cause anything from a package being sent to the wrong address to massive financial mistakes.
Okay, so how do we escape the trap? The solution is a process called normalization. Now that sounds super technical and intimidating, but it's not. It's really just about good organization. It's about breaking things down into smaller, focused tables where every piece of information has one and only one place to live.
So instead of one giant messy table, we're going to create a few specialized ones. We'll have a table just for heroes, nothing but hero info in there. Then we'll have another table just for teams, which lists each team's name and their headquarters exactly once. We could even have one for superpowers. By doing this, we completely eliminate that nasty data duplication, which makes our whole system way more efficient and a heck of a lot more reliable.
But that brings up the million-dollar question, right? If Iron Man is in the heroes table and the Avengers are over in the teams table, how on earth does the database know that they belong together? We've pulled them apart, so how do we put them back together?
The answer is so clever. It's a simple but incredibly powerful concept called keys. These little pieces of data are the magic that allows us to build bridges between our tables and create a single, connected web of information. First up, we have the primary key. Think of this as a unique serial number for every single row in a table. The Avengers team gets an ID of 1, the Justice League gets an ID of 2, and so on. This number is guaranteed to be unique, so we can always, without a doubt, point to one specific record.
And this is where it all connects. The foreign key. This is the bridge. Back in our heroes table, we're going to add a new column. Let's call it Team ID. Now, instead of writing out the word Avengers for Iron Man, we just put the number 1. That's it. It's a little pointer, a reference, that connects that hero directly to the right team in the teams table.
And this just lays it out perfectly. On the left, you've got that repetitive mess from before. And on the right, 2 clean, efficient tables. Now, think about it. If the Avengers move, we make one tiny change in the teams table, just one, and instantly every single hero linked to that ID is updated. The data stays consistent, and it's way, way more efficient. Okay, so we've got this beautifully organized data. Now, how do we actually use it to answer questions? Like, how would we pull up a list of everyone who's on the Avengers?
Let's walk through a really simple example. We want to know what team Spider-Man is on. How does the system figure this out with our new, smarter structure?
The process is actually super simple and logical. First, the database finds Spider-Man in the Heroes table. It looks over at his Team ID column and sees the number 1. Then, it just hops over to the Teams table and looks for the entry with the primary key of 1. Boom! It finds it and reads the name, Avengers. It's fast, it's efficient, and it's always accurate. Now, this whole process of looking up information across different tables and stitching it back together, well, it has a name. It's called a join. It's one of the most fundamental things you can do with a database, and it's what lets us get the full story from our separated, organized data. And what's cool is there are different kinds of joins for different kinds of questions. An inner join, like the one we just did, is like the exclusive club. It only gives you heroes who are actually on a team. But what if you wanted a list of all heroes, including the lone wolves who don't have a team? For that, you'd use something called a left join.
it shows all the heroes, and for the ones without a team, it just leaves that part blank. This gives us incredible flexibility to ask very specific questions.
Now, I know this might all sound a bit manual, like you're constantly looking things up, but here's the great part. Modern programming tools have made working with these linked tables incredibly easy. They do it with something called relationships. See, back in the day, a programmer had to do this whole song and dance. You'd have to tell the database, hey, create the Avengers team. Then you'd have to wait for the database to send back its new ID. Then you could finally create the Iron Man hero, and you'd have to manually plug in that ID you just got. It was tedious, and there were so many places you could mess it up. But today, it's so much smarter. Modern tools let us just define the logic once. We tell our code, hey, a hero belongs to a team, and that's pretty much it. From then on, the system handles all that ID shuffling behind the scenes for us. We can just work with our data naturally, and it just works. It's a huge game changer.
Okay, so we've been talking about superheroes this whole time, but what does this have to do with the real world? Well, it turns out this exact structure is the secret engine running pretty much the entire digital world.
Just think about a weather app. It has thousands of cities. Now imagine if for every single city, it had to store the full country name, United States, its population, its flag. What a colossal waste of space. Instead, they have a countries table, and each city just stores a tiny little country ID. It's efficient, it's scalable, and it's so much easier to manage.
And this isn't just for weather apps. This is everywhere. It's how your bank links transactions to your account. It's how social media links your profile to your posts, and your posts to the comments. This idea, separating data and linking it with keys, is the absolute foundation of modern data management. It's what makes the apps we use every day possible.
So, next time you're scrolling through an app, just take a second and think about it. Think about the hidden structure underneath. What are the tables? How are they probably linked together? You now have the key, pun intended, to understanding the hidden language of the entire digital world around you.